Okay, here we are. We're at a very beautiful spot to pick up where we left off, and we are going to revisit that very first question that we had. The very first question we had was, how do you find the slope of a line tangent to a curve at one point? And so we have two different definitions that we use in order to find that slope. Please watch what I'm doing conceptually. And trust me, I build this in because all of this, everything we do, it really does help prepare you for that exam you take at the end of the year called the AP exam. It's not enough to just know the algebra. Think about what's happening. We have this function, we will call it f of x. We are going to choose a point right here and call it point A. We would like to know the slope of the line that is tangent to the curve at A. So we'll see who's really been paying attention. I can't find the slope at one point. I need 2 points. So what should I do? Let's create a second point. We will call that point X. Anybody remember what we call that line that connects those two? Starts with an S, rhymes with secant. That's the secant line. The slope of the secant line approximates the slope of the tangent line. If we wanted to have a better estimation, what would we do with point X? We would move it closer. Everybody agreed? Okay, so in order to find slope, we do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Agreed? I have my two x values here. I'm missing y values. If this is point A, we plug it into the function to get the y value, and it becomes f of A. So what would the y value for this x value be? F of x. So I have 2 points. Let's do y sub 2 minus y sub 1. Divided by what? X minus A. Does everybody agree that that is the equation for the slope of the secant line? So if we want to know the tangent line, you said take x and do what with it? Move it closer to A. So I know that this is new for you, but this is something we can do mathematically. How do we move x closer to A? That's called a limit. We simply take this and we slap on a limit in front. We say x approaches A. This is equal to your slope. So you may not know it, but through this past unit, in many times, you've actually been finding the slope of that tangent line exactly. And I'll show you how that works. It says find an equation for line tangent to the given function at the given point using this definition number 1. So the function is x squared minus 3. The point is 1, negative 2. So what I have is slope is equal to the limit as x approaches A of f of x minus f of A divided by x minus A. That is our definition. When you look at it, you should be able to think of the picture that it comes from and understand how we came up with that. We don't take anything in mathematics and make it up. We discover the mathematics. It exists. It's a truth. So that is the part that we use. So in order to find an equation for a line tangent, what we need is we need slope and we need a point. I know the point. The point is 1, -2. I don't know the slope. How will we come up with the slope? We will use our first definition. So I have the limit as x approaches what? What is the a value? It is 1 right there. What? We're from the this is the point. So 1, -2. That's this piece right here. An x value of 1 and the y value of -2. Okay. So that's what we're approaching. Okay, the x value. All right, of f of x. What is f of x? X squared minus 3. Minus what? -2. Where'd you get that? If you plug in 1 to the function, 1 squared is 1, minus 3 is -2. It's simply your y value. So -2, so be a plus 2 at that point. Divided by what is on the bottom? X minus what? And the a value is 1. So look at what we have. The limit as x approaches 1 of, what does the top become? X squared minus 1 over x minus 1. So all we've done that's new is we've used this formula. The fact is that we've learned how to solve these limits, haven't we? Yeah, this is a piece of cake upside down. Look, if you plug in 1, what do you get? 0 over 0. Every single time that you find the slope of a line tangent, you always come up with 0 over 0. So how do we reconcile that issue? We do the limit as x approaches 1 of, we factor the top, x plus 1 times x minus 1, divided by x minus 1. What happens? X minus 1's cancel. Can we now plug in the 1? And 1 plus 1 is 2. So the slope is exactly 2. Can we now write our equation for the line? Y minus y1 is equal to m times x minus x1. So we have y minus what? -2. So plus 2 is equal to, slope is 2 times x minus 1. As I work to put that in slope-intercept form, y plus 2 is equal to 2x minus 2. Subtract the 2 and I get y is equal to 2x minus 4. That's the equation for the line tangent. Take out your graphing calculator, please. For my function, I type in y equals x squared minus 3. And what I'm trying to show you now is how to verify your answer. So again, as you grow as a mathematician, you always try to model it with a different problem, find ways to check your answers, look for examples. All those things are really important. So when I'm doing a problem, how does Mr. Gens check his answers? Because often I don't have an answer key. So what I do is I type in the function x squared minus 3, and then I type in the tangent line. 2x minus 4. And if this line is truly tangent to that one, then I should see it just brushing at one point. I'm going to hit zoom 6 or zoom standard, and there we get the x squared minus 3. And look at that line touching tangent right at the point 1, negative 2. I know I've done it correctly. Hopefully you find that somewhat impressive. If you end up with this look, you know you made a mistake, don't you? It is definitely not tangent. I'm not sure. Oh, for here? Yeah. I changed the minus to a plus. So we know we didn't have the correct line. Okay. All right. Let's skip to C. We're going to do C and D. I have 3 minus x squared for the point 1, 2. I have slope and my point. What is my point? 1, 2. So you help me out. I want to find the slope. Slope is equal to the limit as x approaches what? 1 of 3 minus x squared minus 2 over x minus 1. So the slope is the limit as x goes to 1 of, what does the top become? One minus x squared over x minus 1. Similar to the last problem, but slightly different, isn't it? How does 1 minus x squared factor? It is not x minus 1 and x plus 1. It's 1 minus x and 1 plus x divided by x minus 1. Can I cancel off these two? I have to factor out a negative 1 first. So factor out your negative, then cancel them off. Now what? Plug in 1 and you get negative 2. Can we all agree that you know how to write the equation for the line? I think so, right? You go ahead, set up letter D. Set up letter D. You're not going to be able to do the whole thing, but at least set it up. Okay, let's see if you set it up correctly. I, in the top, have x cubed plus x plus 2 over x plus 1. Is that what you have? Do you have x approaching negative 1? I don't even need to plug it in. If I plugged in negative 1, what would I get in the top and bottom? 0 over 0. All the time in these situations. So the whole idea is that we calculate 0 over 0. We'll see if you remember, I don't know how x cubed plus x plus 2 factors, but I promise it does. So how do we go about this process? Good. What do I put in the box? Negative 1. What do I put up top? So negative 1, because negative 1 is the solution to the binomial on the bottom, and then these are the coefficients up above. 1, 0 for the x squared, 1 for the x, and then 2 right there. I start by always dropping this down, and then I multiply. Negative 1, add, negative 1. Multiply, 1. Add, 2. Multiply, negative 2, add, 0. So it turns out when you take x cubed plus x plus 2 and divide it by x plus 1, you get the slope is equal to the limit as x goes to negative 1 of x squared minus x plus 2. Can I now plug in negative 1? Yep, because that thing which was causing the discontinuity is gone. So you could go ahead and plug in the negative 1. I get 1 minus a negative 1, which is 2, plus 2 is 4. And once again, you could write the equation for the line tangent and then graph it. Again, I'm not writing an equation for the line tangent because I know that you guys can already do that and want to save time. We'll do it once more before our lesson is over.
Just like forget the other equation, like would you normally have to write like x plus 1?
So to be clear, what we just discovered is that it factors to x plus 1 times x squared minus x plus 2. And then on the bottom we have that x plus 1. So that's what we discovered by doing our synthetic division. We just knew that these x plus 1s would cancel, which is why we didn't write them again.
Okay.
Is that better? Okay, so the two other types of problems you're going to see are these. And this is where it gets challenging for people and they get a little bit frustrated. Don't get frustrated, you're going to be just fine. Square root of x minus 2 and 6, 2. So what does the graph of square root of x minus 2 look like? Yeah, shifted to the right 2 units. So I want you to tell me anything. Tell me anything about the slope at 6. Go ahead, take 15 seconds, talk to your partner, say anything about the slope tangent at 6. Anything, go, talk. Five, four, three, two, one. Tell me anything. Somebody.
The slope is really small.
Okay, small. So you're saying it's less than 1?
Yeah.
I would agree. Everybody agree it's less than 1? Yes.
I thought you were saying it.
Okay, you're asking. Okay. What else could you say about the slope? So the P rhymes with positive. Positive. Everybody agree it's going to be positive? So notice that when you consider the graph, you can check and see, is my answer reasonable? So let's see if we get this. I'm looking for the slope. I have the limit. As x approaches what? 6 of square root of x minus 2 minus 2 all over x minus 6. Oh no, looks challenging, right? Have we already prepared you for this moment? Yes. I don't know how to isolate the x minus 6, so what do I do? When you don't know how to do the math, you do the Spanish. Multiply by the conjugate. Square root of x minus 2 plus 2. Square root of x minus 2 plus 2. So I now have the limit as x goes to 6 of square root of x minus 2 times square root of x minus 2. X minus 2. Then what? Minus 4 over x minus 6 times the root of x minus 2 plus 2. So the bottom looks ugly, right? But is the bottom that bad? No, the bottom's not that bad at all. So let's check out the top. Let's check out the bottom. Okay, what does the top become? Which will do what? Cancel with this, right? Can we now plug in the 6? 6 minus 2 is 4, plus 2 is 6. I get 1/6. Oh, sorry, 1/4. So, let's write the equation for the line tangent. Y minus what? 2 is equal to 1/4 times x minus 6. So y minus 2 is equal to 1/4 x. 6 times 1/4 would be 6/4 or 3/2. As I add the 2 or I add 4/2 to both sides, I get 1/4 x plus 1/2. I would like to see if my answer is correct, so in here I type the square root of x minus 2. And on the bottom I type in 0.25x plus 0.5. And I graph, and hopefully it looks like one is tangent to the other. And to me, that never gets old. It's beautiful every time I see it. So we're going to give you guys some time at the front end of tomorrow to work. We will finish up letter F tomorrow, but I want you to start working on this piece. See if you can get a couple of these problems done before the bell goes. No, I'm not sorry that I didn't do it. I'm sorry that that's